Hello everyone, welcome back to another video. Today we're going to be covering the product rule for derivatives. Before we move on to integrals, I realized that we need to cover the product rule, quotient rule, and the chain rule. So we'll be covering those before we move on to integrals. So for today, we're going to cover the product rule, and I want to start off with showing you guys the basic of the product rule. So for example, we have a function h of x equivalent to two functions f of x being multiplied to g of x. So when you want to take the product rule or use it, essentially, you have to recognize that we have one big function that encompasses two functions being multiplied together. In this case, f of x and g of x. So when you want to take the derivative of this h of x function, and using the product rule, this is how we break it down. So h prime of x would be equivalent to, okay, so this is where the product rule really comes in. We take the derivative of the first function, f prime of x, multiplied by g of x, just g of x by itself, the regular, then plus. And the product rule is defined by this addition sign that comes in between f prime of x and g of x. But then on the other side of the addition sign, we have f of x, just regular f of x, times g prime of x. Now we're taking the derivative of g prime. So this is the formula or the rule of the product rule. This is how you take it. So again, bigger function, h of x, take the derivative of that. It is equivalent to f prime of x, one of the functions, taking the derivative of one of the functions, times g of x, the second function, just regular, plus f of x times g prime of x. And if this is kind of like confusing or just a little bit complex, this is how I like to think about it. So in general, we have to take the derivative of one of the functions. So for example, again, if you could write this as g prime of x, and then f of x, and then, for example, this could be f prime of x times g of x. So I like to think of it and make sure that we're taking the derivative of one of the functions on either side of the addition sign. And I like to think of the addition sign as a boundary, separating the derivative of one of the functions, if that makes sense. We'll go over an example of how to do this, but again, just keep in mind that we need to take the derivative of either f of x or g of x on one hand of the addition sign, which we took f prime of x on the left. And then on the other side, we need to take the derivative of the other function, which I took g prime of x. So let's use or go analyze an example of this. And let me just erase this. And then let me also, I want to keep this formula as a reference so that we know what we're doing with the product rule and how we're doing it. So I'll put this up here and move my camera a little bit down there. Just that. There we go. Awesome. And I will also delete this guy. Awesome. All right. So let's take, for example, h of x is equal to 6x squared times 5x cubed plus 4. Let's spread the parentheses. Okay. So we don't have f of x and g of x technically defined or written out, but we can make out that, for example, we can call 6x squared as our f of x function, and the 5x cubed plus 4 our g of x function. All right. And I think I also need to move this a little bit up. Make some room. Cool. So again, considering that formula that I have above me, we want to take f prime of x, okay? So I define f of x as 6x squared. So let's take a derivative of 6x squared. So again, what I like to do is I like to break up the coefficient. Just take the derivative of x squared Our exponent is 2, bring that down, 2x, and then our exponent was 2 originally, just subtract that by 1, bring that down, that's 2x to the first power. Take that original coefficient, 6, 6 times 2x equals 12x. Cool. So that is f prime of x. Okay. And then we already have g of x. But since we have g prime of x on the right-hand side of the addition sign, eventually we need to take the derivative of g of x, right? So let's just do that. So the derivative of g of x, we have 5x cubed plus 4. Okay. So we already know that the derivative of 4 is going to be 0. So let me write this out. 5x cubed plus 4. The derivative of that, we know 4 is just a constant, so that's equal to 0. So all we have to focus on is just a 5x cubed. So again, 5x cubed, focus on that. That's our coefficient 5. Break that off. So x cubed, derivative of that. Bring the 3 down as our coefficient from our exponent, 3x, and then 3 was our original exponent, 3 minus 1 is equivalent to 2, so we bring that down or up as our exponent. So that is g prime of x. Okay. So f prime of x was 12x. So let me kind of make things nicer here with more room. Cool. And then let's remove this. It's all messy. Okay, awesome. So again, let me write this out. F prime of x was 12x, correct? And then g prime of x was, and I forgot to multiply the 3 by the 5, but that would have been 5 times 3x squared. My apologies. That would be 15x squared. So g prime of x was 15x squared. Now, again, let's consider that formula above me. All we need to do is just plug in our values. So f prime of x, we had 12x, correct? And then g of x, we already have g of x here. That is our function above us. So 12x times 5x cubed plus 4. And then addition sign as shown above us in that formula. Plus, we have f of x, which is just 6x squared. As you can see here, that's f of x. And then multiply by g prime of x, which we found, which was 15x squared. Cool. And that's it. Basically, h prime of x is equal to all of this. And now you can also simplify this by actually like multiplying, distributing the 12x to each term here, and then combining the 6x squared and 15x squared. But yeah, that's just for simplification. But the big idea of the product rule is to recognize two functions being multiplied together. And also just recognize the formula too. If you need to write out the formula first, in this case, as you can see above me, it's f prime of x, g of x plus f of x times g prime of x. Just write the formula out, but you need to know the formula, of course, but write it out first. And then when you have the problem in front of you, just break down the two functions that you have, take the derivative of both functions as I organize it here. And then after you have the derivative of both functions, all you need to do is just plug and chug in that formula, because originally you already need the f of x, your original functions, and the derivatives of the functions, and that's it. You will have the product rule in your hands, basically ready to go, and you'll complete the derivative of h of x pertaining to the two functions or encompassing the two functions that you have. So I think just in general, the product rule is all about breaking down the two functions that you have, using the formula, but just organizing everything before that, plugging and chugging to the formula, and it'll make everything just much easier. So that's pretty much it about the product rule. I hope you guys enjoyed the video, took something away, learned how to do the product rule in terms of organizing it, breaking the functions down. So hopefully that was just an efficient way, convenient way of doing it. And with that being said, again, I hope you guys enjoyed the video, and I will be covering the quotient rule and chain rule together in my next video. And then from there, we'll move on to integrals. So thank you so much, guys, again. I'll see you in the next one.